So looking at objectives. And what I want to cover today is a somewhat narrow topic, web application session strength. And what that really implies is how is session management handled in a web application, and how can it be handled, what happens when it's handled poorly, how can it be handled well, and some of the implications. Basically, those implications are going to be, impersonating someone else or stealing someone else's information, be it username and password, email address, or financial information. One of the important things that I think I wanted to talk about session strength was that it's not like syntax errors. The well-known attacks are SQL injection and HTML injection, or cross-site scripting. And those are very easy attacks to launch. They're easy attacks to look at because they just rely on modifying the syntax of a URL. Insert an apostrophe here, insert a couple script tags there, and you have an attack that's successful. I think those are valid, but it's also important to understand that even if you have good input validation filters, that's not necessarily going to defend your application as much as you need it to. So as I was saying, syntax errors are they're very common. They're somewhat easy to fix from the perspective of coding. You can apply input validation filters throughout your system. Now I'm going to take one quick divergence here, and if anyone's familiar with Windows XP and the issue of raw sockets, that Windows XP as a security measure is considering dropping raw socket support from the Service Pack 2. Now, whatever your opinion is about this, you may or may not agree that we could do the same thing. We could also improve security by dropping apostrophe support from Internet Explorer or even from IIS. So, for example, like raw sockets, you have to hack into a site through a poor configuration, buffer overflow, something like that. Then raw sockets allow you to run an IRC or run a distributed denial of service. If we remove the apostrophe from IIS or the apostrophe from Internet Explorer, voila, our security woes would be over. And just in case you aren't familiar with the raw sockets issues and security implications, I am being a little bit sarcastic with that. So if you do decide to email Microsoft, don't blame me. Let's go back to session state. So quick overview. Session state is necessary because HTTP is a stateless protocol. All the information it receives are very discrete packets. So that just basically means that you're going to Amazon and you're buying a book, you're putting that book in your cart, you decide to go to checkout, but then you want to add another book, so you add another book to your cart, maybe you add some DVDs, or maybe you add something else to the cart. And through all of this transaction, the web server has to keep track that Joe is putting all of Joe's books into one cart and Alice is putting all of her books into another cart, and basically have to keep that information separate, especially because when you go to the checkout process, Joe should not be presented with Alice's credit card information. And one final note, throughout I'll talk about session tokens because session cookies, there's a very specific definition of a session cookie. They're only valid while a browser is open, while a browser exists. And many times web applications will handle sessions with that cookie, but there are many other places where the session token, in other words, that identifier that identifies the user to the server, can be tracked. It can be tracked within form fields, it can be tracked within headers, and it can also be tracked within cookies. So what are the threats? Why should we worry about session strength, session security? The goal of the attack is you want to access information under someone else's credentials. And this is similar to brute force. It's very similar to guessing someone's username and password, but it can actually be somewhat simpler than having to guess two pieces of information. You don't have to know a valid account name and a valid password. If I want to attack Alice, I have to find out Alice's username and Alice's password. However, if I want to do a session attack and I want to actually attack the session identifier, the session cookie that identifies Alice, perhaps I just need to guess a single random number. But perhaps that number isn't too random and we can guess it based on timestamps or something like that. By the same token, we can't necessarily attack one particular user. If we wanted to attack Alice, we would log in with Alice's username, then we'd try and guess different passwords. However, with lots of brute force session attacks, you have a larger target pool because you're just guessing numbers. So you're not necessarily going to get Alice, you might get Bob or Charles, but either way, you're going to get someone else's critical information. Additionally, too, you don't have to target a single page in the web application. For example, using a brute force attack, you have to target the username and password login page. With a session ID, you just have to attack a part of the web application, one of the URLs that accepts that session cookie. That could be when you view your profile, it could be on a checkout page, it could be on the login page, it could be on the home page. So what that implies is that this type of attack, this type of brute force attack, can be a lot harder to identify based on heuristics, because you don't have to make 1,000 requests for the same login.asp, for example. You can distribute those 1,000 requests amongst 50 or 100 different URLs. And finally, session IDs are should be better than usernames and passwords, because you can control the key space, you can control the entropy of the values and how random these values are going to be. So do a quick talk about key spaces and what I mean by that. If you have a username, let's just imagine that your username should be 6 characters. You have 64 symbols, which is pretty much alphanumeric and perhaps the @ symbol. With that, your key space is about 36 bits large. If your password can be alphanumeric and add punctuation, you have about 96 different characters, and you have a key space that's about 40 bits big. When you talk about session IDs, often those random values, they're just going to be a 32-bit value or 64-bit or 128 or 256 value. Now, those sound large, but those aren't necessarily large. For example, a 128-bit value can be easily created with an MD5 hash. Same with the 256-bit value can be created with a SHA hash. But I'll show a little bit later that just because you have a large amount of bits does not mean that you have a very large amount of entropy, and it doesn't mean that your session IDs that are supposed to be random are actually well protected. This is just another point about key spaces and why the login, you still want to have a strong username and password to complement your session strength, because humans are very poor entropy generators. They'll have poor passwords, your username is password, or password1, or password foo, or you try and, substitute letters with vowels, or numbers and vowels. Even strict password policies can reduce the key space. And I just threw a bunch of notes up there that, for example, if you had a strict password policy that said your password must be 6 characters, it must contain 1 digit and 1 special character. Consider that punctuation. Your key space is only about 30 bits, whereas out of 96 possible symbols, it should have been about 40 bits in size. So these are still very large numbers. It still doesn't mean that your brute force attack is going to be that much easier, especially against a website and across the network. But what it means is that you have a very significant reduction in the amount of randomness or in the amount of possible keys or possible values that an attacker has to guess. And it's important to take this type of thinking and just illustrate with usernames and passwords, because that's the exact type of correlation that I want to make with random numbers or not so random numbers. So we have basically 3 different types of session attacks. You can analyze the token for deterministic string content. That means that the session ID is actually your username, or maybe it's your user ID, or maybe it's just based on your email address. So after you log in, you have to provide your username and password. The application accepts you, identifies you as authenticated, and then just tracks you throughout the application based on your username. That's very poor. That can be strong user authentication, but very poor session management, because it's very trivial to guess someone else's username and just go through a list of different email addresses until you get a valid user. You can predict a token. By doing that, you're looking for some mathematical property that it has. It may be that it has very low entropy. It may be based on timestamps. It may be permanently increasing in steps of 1, or maybe permanently increasing in steps of 100. You can apply some types of regression models or some statistical analysis to see, hey, how random is this token, and am I actually going to be able to model it or be able to model a very small window so that I only have to make 1,000 guesses in order to get a hit, rather than 50,000 guesses in order to get a hit. And finally, you can also just guess a token. And that way, you're just blindly, you've taken a cookie and you've said, well, this is what it looks like. I'm just going to start messing with values just to see what happens. And you may get lucky and you may not. So these are, an important thing about these types of attacks is that what you're attacking at is the server. You're directing your attack towards the server, but your victim is actually other users of the application. The session attacks are done in order to steal, to grab someone else's password, or to grab their personal information, or basically to view your personal profile page. So you're attacking someone else, much like cross-site scripting tends to attack other users of the system rather than the actual system itself. So you're not using a session attack to grab everything out of the database. You're doing this to grab other users. And what's important is that depending on how the token is created and managed, that the other users don't have to actually be active on the system. So it's basically just a one-to-one.
For example, what about if they're going using a cafe, cyber cafe, you just regionally get the token and then it passes off another, you break it down their computer?
Absolutely. The question was, what about stealing it? And I actually have the next slide describing user-directed attacks. And in those cases, those types of attacks are just as legitimate against web applications. And in that case, you can sniff it with, if it's clear text, TCP dump, dsniff on a wireless network, you can sniff it that way. You can hijack someone's session as well, and you can also just steal it, either if it's in a shared internet cafe where you can sniff the browser, or you just walk up to the browser after someone has left, click the back button, and perhaps they didn't even log out of the application. So there are many different ways of attacking the session management, and I wanted to focus on the server-directed attacks rather than these types of user-directed attacks, because protecting against sniffing, protecting against theft can often be dealt with in other layers besides the application layer, and in fact, it can also be difficult to defend against in the application layer. So the question is, the main focus is, how do I figure out which value is used as a session token, and then how do I figure out if that session token is random? How can I figure out if I can predict it, or how long is it going to take me to guess a valid token? So I have about 4 live examples that will just describe the implications of how they manage tokens and what that means. So, and a lot of this is going to be relative security. I don't necessarily believe that a static token, which I'll describe and define in a little bit, can be more or less secure than a dynamic token, and vice versa. It's very relative to the implementation and how you manage a session cookie, how you manage this piece of information. Because the session token is basically equivalent to a password. It identifies that user. And so it has to be treated as a confidential piece of information. So we have 2 types of token creation, I should say, rather than token management. You can have a static token. What that means is that whenever you log into a web application, you receive the same token value every single time. That means you enter your username and password, and on a Monday, you're given a session ID or a session token that says Mike12345, or it says Jane89897B. And if you logged in and then if you logged out and you logged back in on Wednesday, you would get that exact same token. So in other words, that session token is static for that particular user. Now, when that happens, your target pool is actually all users of the application. If you can figure out how a token is created, then you can say, oh, it's the username plus a 5-digit random number. You can say, aha, all I need to do is find out all of these people usernames and a 5-digit random number, because that token is valid on the application 24 hours a day, 7 days a week. So your target pool suddenly is increased. So if you're launching an attack and you want to try and you can send 10,000 guesses per hour, then in those 10,000 guesses, your chances of getting a hit are much higher than if these tokens were actually dynamic. A dynamic token means that you get a different random number each time you log into the application. So you log in on Monday, you get a 32-bit number. You log out, you log in on Tuesday, you get an entirely different number. What this implies is that your target pool, in other words, the amount of valid tokens that are available to you when you launch your 10,000 guesses is much smaller. So it's basically plain probability. Your dartboard with a dynamic token tends to be smaller than if you're using a static token. So And this assumes that you're creating it in a very random manner, because you can still then encrypt yourself if you have a dynamic token that is just simply time of day plus 1 or time of day times 2, some type of simple transformation. So, and dynamic tokens, just to give you an idea of what those are, would be the ASP session ID, PHP session ID, J session ID. These are the types of tokens that are created by the application engines. And then on the code end, you actually have a server object that you can query, that you can give users tokens. That's the one you manage. So go ahead, and now I want to talk about a couple examples, give you that way we can talk about some real life scenarios and give you an idea of what this really means and how this looks like in the wild on the internet. So the first example is a token in a cookie. It's a static token and it's trivially deterministic content. So I'll go over what static is and why it's so easy. You have, for example, thinkgeek.com, and when you log in, it gives you a nice welcome, and it tells you what your user number is. And I have it circled in red there. If you can't see, the number is 12F93A9. That's a very simple number. It's a 16 digits, and it's hexadecimal. Now, if we were looking at the token, what we would want, the cookie value during the request, we see that there are several cookies here. When we want to automate, or if we want to manually go through the process of actually trying to figure out which of these tokens handles the session, we have to go through and we have to say, okay, we'll submit our request with cookie equals true, or we'll delete the first cookie, send a request, and we'll see if we get back this page. Then we'll delete the second cookie, so we'll only be sending 2 out of the 4 cookies. We'll send the request, see if we get back this page. We'll continue to delete cookies until we only get to a combination of 1 or 2 cookies that gives us this page, in other words, a valid page. So out of the 4 cookies that are set in this site, only 2 are required to identify the session. One is called the lucky monkey, and one is the spunky monkey. And only of those 2, only 1 is required to actually identify a user. So in reality, what we have here are 4 cookies, 2 of which are necessary for a session, however, only 1 of which is necessary to identify the user. So what this means is that if I'm an attacker and I want to target someone randomly, I have to, of the 4 cookies that I receive, I only need to guess 1 of them. So what I would do then is I would start to, sorry, I keep switching around, is I would take this cookie string and I take the lucky monkey value here, that's 12F93A9, and I just create a loop. I create a value 1230000, and I just increment that for however many times I wish, and I keep sending out this request, and I'll collect and see whenever I get a hit. Now I did this, and over 10,000 requests, I got 270 different valid accounts over a period of about 3 hours, just because I was doing this request very slowly. So this is an example of a static token. This lucky monkey value is your user ID basically, and that's what identifies you when you log in. It never changes whether or not you're logged in. Plus, I can attack someone by grabbing their email addresses by just guessing this value, and they don't have to be logged in. For example, if I was doing a cross-site scripting attack that was trying to steal their password or steal something about them, they would actually have to be logged into the application. They would have to navigate to my cross-site scripting payload, and bam, they're hit. In this case, they can be at home asleep in bed, and I'm attacking the accounts and I'm collecting email addresses. So this is the user identifier and the session identifier are independent in this case. In other words, you can authenticate to the system, and you get a username, you submit your username and password, and the server gives you a token that identifies you. However, that token is not tied to you actually being successfully authenticated. That token is just static every single time. So that's really an authorization problem. It also implicitly trusts the client side. It implicitly trusts that you're sending the correct lucky monkey value for your username. Obviously, anything sent to the client can be manipulated, so I can simply change the value from me to someone else. Also, the lucky monkey value is derived from a very small pool of numbers. Now, 16 to the 7th is actually about 270 million different values. That sounds like a large number. However, it's even with that value, if there are only about 26,000 or 27,000 users of this website, if I send 10,000 guesses per hour, in 1 hour, I have just about 100% chance of getting at least one valid account. And in this case, I got about 270 valid accounts. So it's very, very simple. One of the reasons this was an insecure token was that it always increased as well. So that if I log in and I get 12345 as user ID, then all I have to do is wait a week, and I know that after a week, if any new user that is logged into this application has a token that's greater than 12345, and I log in a week later, I see and create a new account, I see what account number that is, and now I have a window of a starting value and an ending value, and perhaps there's a range of 50,000 potential users. I can just target 50,000 different user IDs until I get a valid one. So that's another reason that session tokens should be taken from a uniformly distributed random pool. So in this, a little bit more about the attack. It's only done in actually I did 168 minutes of work. It took 2 minutes to write a for loop, and 160 minutes to wait and watch it collect email addresses. And of course, you can do this type of attack can be done if you want to do more than one request per second, and you want to do this over, instead of a period of 2 or 3 hours, you can do it over a period of a week. The other problem with the static token is that the attacker is not limited in any way by session timeouts. It's not limited in any way by activity of the site. You can do this in a manner that flies below the radar, because the user ID 12345 is always valid on the web application. So I could do my attack 1 per hour over a period of a week, and perhaps I'm going to get, and I'm never going to show up in an IDS log, and perhaps I'll get some valid hits. So we move on to the next one, and I'm going to talk about Pepsi. And it's very, very simple. I talked about, this time the token is encoded, and it's actually stored in HTML, in an HTML form, and a hidden form tag. So just an example of a login page. Once again, this is just a very simple join Pepsi's marketing email. There's nothing too exciting here, but it does demonstrate the request now. Is actually the HTTP request. If you notice in the cookie, there are 2 ASP session ID cookies being sent here. Well, at first this looks good, because this looks like it means that the web application is actually relying on the ASP session ID. It's using a server-side session management. However, if we start to play around with it, we'll notice that none of the ASP session ID cookies are actually used. So they're being set simply because by default IIS is sending them, but the application isn't using them. So that's bad step number 1. However, you do have to have a valid username and password to be able to log into this system, and you can't target other users just by changing the post data down here in the bottom. So you actually have to, so session management is basically defined by submit your username and password every single time. It works for this type of web application because there's only 2 pages. One is to update your profile, and the second one is to verify the update. So that's why, in this case, it's not too bad. So the session integrity is well kept. However, the session confidentiality is still another matter. And this is where we have an encoded base64 value, as well as your own password in clear text set in the actual HTML of the website. So this illustrates a point where even if you have a strong session management, if you're doing everything over HTTP, and if you're doing everything, someone can just sniff the attack, and they'll get your username, they'll get your password, they'll get session information. In this case, there's a token called session ID, and if we do a base64 decode on it, we'll see that there's some interesting stuff in there. We have an email address, and we have a timestamp. So already, if there's potentially, unfortunately this one doesn't have anything too exciting besides an email address and a timestamp, but it shows that encoding is not necessarily a step for security. It's just there to obfuscate something, but we can still delve into it and find what type of information is in the web app. A couple more observations about this Pepsi example is that the session ID value doesn't contain any sensitive information that's already included elsewhere in plain text. For example, looking at this HTML snippet, you already have this hidden tag which has your username and another hidden tag that has your password. So it doesn't really matter if you have strong session management because everything is done over HTTP and your username and password are being echoed back in plain text. So this is a type where you need to have strong confidentiality implemented as well as strong session management. Now, again, in the ThinkGeek example, I was able to log in and get my own session user ID and then just start replaying other session IDs until I was successful. In this case, I actually have to, every time I try to guess someone's user ID, I actually have to submit their password as well. So in this case, I'm not going to be able to sit down and write a simple for loop and enumerate users of the application. Another example of session management, of cookie manipulation or token management is Hotmail. And more specifically or more generally is Passport. In this case, Passport uses two cookies to identify users. It uses an MSP auth cookie and an MSP prof cookie. Both of these are base 64 encoded values, but they're also encrypted with triple DES. So they're very secure. In other words, I'm not going to be able to do what I did with Pepsi and just do a base 64 decode and see my email address and see a timestamp. So I would actually have to be able to decrypt this information and see what type of profile is stored here, what type of user authentication or authorization or access roles are defined within this cookie. So this is a more secure method of token management, but it also means that you have to have encryption, and which can be a performance impact on your web application. Now, of course, Microsoft and Passport are able to throw 10,000 plus web servers and handle a lot of this, so you don't have to worry about it as much. However, there are still threats to this where you can replay these cookies. For example, these two cookies that I put up here, I changed them a little bit so that they wouldn't be valid, but if you were to take two valid MSP prof and MSP auth cookies from someone else, you could replay them and you could actually impersonate that user and basically be there inside their Passport account or Hotmail account and not have to have their username and password. So this is another example why session strength and grabbing session cookies and session tokens are a good way to bypass secure brute force measures. iTunes Music Store is another one that's interesting. This example shows a mix of static and random tokens, and instead of being placed within a cookie, or instead of being placed within the HTML in a hidden form tag, iTunes actually creates custom headers. So we have the iTunes Music Store, and here's a simple GET request for it. You can see there's an X token and an XDSID header that have been set. The combination of those two is what is used to handle the user session. So if I were able to guess someone's X token and XSID value, then I could go and look and see what's in their shopping cart, for example, and I can impersonate that user and I don't have to guess their username and password. So, and if we break it down, we notice that even though the X token seems to be a very large number, it's really just a timestamp. And in fact, it's not even a timestamp that's going to be difficult for us to attack. That's the random part of this value. There's only 86,400 seconds in a day. So that limits our attack pool right there. However, the XDSID token is about it's an 8 to 9 digit number. It's probably a 32-bit number. And that one is static for everyone. But that one is random for everyone. But what happens is that we have to guess a combination of those two. So still, we have a very large pool that's going to be difficult for us to attack. So this is an example of a mix of a static token and a dynamic token, but it's still going to be resistant to us trying to guess what's going on. Another one, I think this is my final example, is slash code. For example, start on / dot, or I just chose to throw up here an example of max slash. What this is, an example of a static token, again, that's static for the user every time you log in. If you look at the cookie value, initially you get a lot of URL encoded characters that once you start decoding them, you get basically to a 5-digit number, which is your user ID, followed by 2 colons, followed by the MD5 sum hash of your password. Now, there are two different things about this. One, is that you can reverse engineer the password. That if you were able to get someone else's cookie value, you can just dump this MD5 sum into John the Ripper or into something like that, and you can brute force their password. It's offline attack, so that's easy. And that's pretty well known. What I want to highlight with this is just why static tokens can be very bad, because one of the reasons that in this case the key space, the entropy or the randomness of your token, of your session cookie, is highly influenced by the user. It's basically based on your password. So even though an MD5 sum can be a 128-bit value and might look very random, in reality it may not be. If my password is only ABC or my password is foobar or something like that, it's going to be very trivial to attack that because humans aren't very good entropy generators. Also, in the event of a compromise or just for the administrator's edification, the token can't be changed or can't be regenerated without any interaction from the user. So for example, if you are worried about, if you want to do a reset of all of your session IDs, or if you want to reseed your session management functions, or if you want to do a small modification in your session management, the tokens, the actual cookies that your management is using are all controlled by the users because they're based on the user ID and they're based on their password. So even if I wanted to disable someone's, if I wanted to protect someone because I think they've been using an internet cafe and I want to change their session cookie, their session token, I can't because it's based on a password. It's static for the entire time. So that's what another drawback of having a static token is versus a dynamic token such as the ASP session ID. Additionally, and the final bullet point there is that in this case, the token can be attacked offline because it's the MD5 sum of your password. So rather than just launching a bunch of guesses at the server, you just grab the token, do a brute force attack, and you've got their complete access to this user. So again, a summary about static tokens is that with the static token, the user is not inhibited at all by session expiration. Even if you have a session expiration that if there's a period of inactivity after 30 minutes or after 2 hours, or even if there's a logout button on the application, that session token, that session cookie, is not protected by that. The attacker can still launch it because that session cookie is still valid on the server. Additionally, the victim doesn't actually have to be active. A static token means that the victim doesn't actually have to be going through news groups, looking at their financial information, reading through forums in order for the attack to succeed. The probability of success also increases with the number of total users of the system. In other words, if you have say a medium with bandwidth web or medium-sized website that gets perhaps 1,000 hits per hour, for a dynamic token, you have a chance, you have a target pool of 1,000. If, however, there are 1 million users of that application and they use static tokens, you have a target pool of 1 million users. That's a phenomenal difference in your chances of guessing a valid token. It's also more likely to enable the attacker to target a specific victim. And a lot of times if there's a deterministic content such as a username or such as an email address or a user ID, then it can be very easy to see if it's a forum, to see what other usernames are or to see what other email addresses are and attack that as part of the token. Dynamic tokens, on the other hand, if they're taken from a random pool and if they're properly handled, inhibits the attacker because now session expiration means something. If the session token is only valid for 20 minutes before the user actually, after inactivity, then you only have a 20-minute time period of guessing a valid token. Additionally, your target pool, like I said, is only equal to the size of the number of active users on the application rather than the number of total users. And that's only going to be less than the number of total users. So you've also limited the attack space that the attacker has available. So with the dynamic tokens, going down that route, which is much better route, you still have to have a very strongly generated, strongly random token. Now you can do this with some different, you can do this mathematically to identify, is my pseudo-random number generator actually generating something that's random? Is it working? Can someone create, sine A plus cosine B that actually models what I thought was a pretty good random number generator? And you can do this through entropy, doing Fourier analysis, looking for frequency dependencies, looking for different associations with times, and nonlinear time series. This third bullet, the nonlinear time series, if you're familiar with the BindView paper that came out 2 or 3 years ago, they applied a very similar thing to the TCP/IP initial sequence number, so predicting initial sequence numbers. And I have a couple of graphs that I'll show off there. One of the good things that you can do is to do a phase space analysis. What this means is this is similar to the BindView paper. It's taking a string of random numbers or a string of observed values, and you basically map them, you map their differences, or you map them so that the value at time sequence 1 is subtracted from the value at time sequence n plus 1. And you do that, and what that does, it actually acts like a high-pass filter. It reduces a lot of trend information. For example, when you do this, it can very easily identify that you have increasing values. If you have a session ID that goes 1, then 2, then 3, then 4, then 5, if you do phase space analysis on it, or if you do a difference of them, so if you take the value at time 1 and then the value at time 2 and you subtract them, it's going to be it's going to be a constant value, so it'll be a constant value of 1. And it's a lot easier to identify that this is a random number generator that actually is not random at all. You can also do some entropy calculations. Again, this just basically is a product of the probability of a number showing up times its log. Again, you need very large sample spaces to do this. This is why, in practicality, it's not necessarily, you actually have to have large observation times. You need perhaps 10,000 values or 20,000 values to see if a random number generator is truly random. So that's why I have just the math here and not actual code that goes through it. More importantly, and part of the reason there too is that if you rely on the ASP session ID and the PHP session ID, in other words, the application generated tokens or generated sessions, those are the ones to rely on. And those are the ones to use properly because a lot of work has gone into producing them. And it's the same idea with crypto, that everyone admonishes you, don't try and roll your own encryption scheme because you're bound to make mistakes. And even with encryption schemes, for example, DVD, the DVD CSS, that was broken not because DES was broken or because the encryption was broken. It was broken because of poor key management. Someone was able to see a key. The same with being able to run Linux on your Xbox using the MechWarrior CD, the MechWarrior game. The way to do that was done not because someone broke the encryption scheme, but because someone broke the key management. The same thing can be applied with session management, that use the ASP session ID object, use the session object, use your PHP session object, rather than trying to create your own session identifiers and trying to say, I'm going to have a username plus a 32-bit value plus a timestamp. That can lead you down to some very insecure paths. Additionally, too, transformation does not increase randomness. In other words, let's just say you're going to give everyone a timestamp of when they log in, and that's their session token. You can do that, the date plus %s. If you do that from the Unix command line, you'll get the date, the timestamp. That's a 32-bit value, but it's not a very random value. If you take the MD5 hash of that, you can create a 128-bit value. Well, that sounds like better, doesn't it? Or the SHA-1 hash of that creates a 256-bit value. But in all three of those cases, you haven't increased the randomness, you haven't increased the entropy, you haven't increased any of the security of that token. So that's why it's not a matter of bits, or it's not a matter of the size of the session token that necessarily implies how secure it is. It's actually how random it is, or what's the entropy of that token. Because you can still trivially guess these, and your seeds are still really small. And as I've been saying, so you have many web servers, web applications that have methods to provide the random session IDs, and these are the ones that it's much better to use and use properly. And they're the ones that you can trust, and you want to say these are generated randomly. Very quickly, if you've seen, I have 4 graphs here that show quote unquote the randomness of these values. And for example, this is a phase space diagram of the ASP session ID. Basically, the interpretation of a graph like this, basically, you look at it and you say, how large is it? In this case, when this axis is is 2 times 10 to the 50th. So we have at least a large range. The next question you ask yourself, does it have a large dispersal around it? And if it has a large distribution, that implies there's a uniform distribution around here and it's very random. So if you do a phase-space analysis of your session token, and you plot it, you see a widely dispersed graph, you're going to say, oh, there's no time dependency here. It looks like it probably is a very random value. If you do a session, if this is the .NET session ID, again, it's about 4 times 10 to the 50th. So we have very large range, but you notice clumping. Now in this case, it seems like maybe perhaps there's less randomness here because there's clumping. There might be more of a time dependency. Now, in this fact, this clumping is only because we have a small observation pool. We only did about 4,000 values collected. So even though we only collected 4 values, it looks like it may not be too random because there's clumping. But if you were actually to extend this over a longer period of time, a longer observation time, you see that the dispersal of it would grow and grow. So it's basically what I'm saying is I'm just making another case that use the ASP session ID, use the .NET session ID tokens, because at least from this point of view, they do appear random. Same thing with PHP. PHP has gone through a couple iterations of insecurity and security versus the generation of their tokens. Now from PHP 4.0 series, from which this is gathered, you can see that the graph shows a very, very dispersed distribution. So once again, that implies that there's not a heavy time dependency, which implies then that it's going to be more difficult to predict and model this type of random number generator. Finally, one more is the J session ID generated through Java application engines. Once again, this just shows that the application engine provides a session management, provides a random value that is in fact going to be very random and probably sufficient for any needs that you're going to run into. Now, and the importance then is to use these dynamic tokens, assign these dynamic tokens to the user, and then apply the authorization and authentication information to these tokens, not to add additional cookies that say username equals this or that you can modify during attacks. So talking about countermeasures then, you have, of course, input validation you always need, strong passwords and authentication systems you always need, but a session attack renders both of those pretty much useless because it's hard to predict it, it's hard to protect this from a session ID attack with an IDS, and it's hard to protect against a session attack through input validation filters. So what should a session token do? What should this session cookie do for on your website? What it should do, it should temporarily identify the user with a session token. And that identification does not have to be based on an attribute of the user. In other words, that attribute doesn't have to mean that it's based on the username, it's based on the email address. It just has to be something that's random, that's a random value that for this 20 minutes or so, or 30 minutes, identifies the user. The session token or any cookies should not describe the user. In other words, it shouldn't have profile information, once again, the username or the password. It definitely should not have privilege information, such as user or admin, because privilege information can lead you to other types of semantic attacks where you flip a cookie that says is admin equals false to is admin equals true. Suddenly you've logged in as your own user, but you've given yourself elevated privileges. And also it shouldn't contain sensitive information, this PPA or PPI information such as your social security number, such as financial information, bank account, credit card information. None of that should be associated with the session token that's being passed to the client. What they should be done is being handled on the server side, so that the server says, okay, here's my session ID, my session token, I'm going to store in memory the username associated with this random value or the social security number associated with this random number, and every request does a lookup in memory of that value. So that's why the server-side session objects should describe the user, should give the site privileges, the profile information, the data privileges, what they can access. Additionally, session expiration is very important to session management. You should expire under several circumstances. The logout button. The logout button should work. If the logout button just redirects you to the home page, but it doesn't delete the cookie from the client, and it doesn't delete the cookie from the server, then in an internet cafe, someone just needs to walk up to that server, click the back button, and they're still logged in as you. they can change your password, they can update your profile, they can change the email address so that you can request a new password and have it emailed to you. Additionally, there should be, depending on the sensitivity of your application, the session should expire or force the user to re-authenticate after a set period of time. For if you're doing a financial application where you're handling bank account or trading information, you may want to force the user to re-authenticate every 30 minutes or perhaps every 45 minutes, regardless of inactivity, just to make sure that the user is still who they say they are, and just to reinforce the security of that session. Then, of course, session inactivity after a period of 20 minutes, 30 minutes, 40 minutes, perhaps 2 hours, 8 hours, you should always expire those tokens, because the longer that session token is valid on the server, the longer it's there for it to be attacked and the larger pool you have to attack. So by reducing it, you help for environments where physical access is very hard to control to a computer, or computers are in shared environments, and also decreases the target pool that attackers have towards that token. One question?
If you do any metrics, it sounds like the three things you need to look for is time, number of users, and time period of time, as a key space. So if you do any metrics to say, if I'm using this key space and I need to have this kind of timeouts, or I need to have limits to this number of users, and I have to go to a bigger number of users, and I got to increase my key space or decrease my timeout.
Right. The question is what's the correlation? What are the good guidelines to be able to say I have n amount of users, n amount of requests, say requests per hour, valid users per hour. What should the session timeout be, and what should the key space? How big is a 32-bit value sufficient? Is a 64-bit value sufficient? The answer to that is I had a slide that had those metrics, and initially what I found is that if you have a high bandwidth website, a million hits per day, and say you have 10,000 concurrent users per hour, and you have a session timeout of 20 minutes. So you have 10,000 users per hour, a session window, a timeout window of 20 minutes, and you're using a 32-bit value. During that time, if I launch the attack of, it was 10,000 requests per second or 10,000 requests, at 1 request per second, I still had a percent chance of about 0.0027 to guess it, even with a 32-bit value. Now that assumes that you're using dynamic tokens. So a 32-bit value can still be pretty secure even for large bandwidth websites. If you have, so I think 1,000 users per 10,000 users per hour, and you have a session timeout of 20 minutes, 32 bits can actually be sufficient. However, that 32 bits does have to be random, and you have to make sure you do all the other caveats, such as expiring it and doing session timeout. So initially, I didn't think there was too much of a difference between 32-bit and 64-bit. One of the side thoughts I had on that was that with 32 bits, however, you still may have a potential for someone profiling your random number generator. Because right now you have getting close to a lot of storage space, so it's very easy to put 1 terabyte of storage space onto a desktop computer, or 2 or 3 desktop computers, and you have very high amount of CPU utilization available to you. So what you can do is you can take a 32-bit random number generator, you can take, say, the first 1,000 values, and then you can say, okay, these are all the seeds that produce these values. And you can profile someone's random number generator. And that's a bit of an aside, and I don't have any good metrics on the feasibility of that attack. That's perhaps a white paper for something else. But the long-winded answer to that was if you use dynamic tokens, and you have small time windows. In other words, you only expect people to be active between 20 and 30 minutes on your website, and you have a high amount of users, 10,000 unique users per hour, then 32-bit values, it can still mean that an attacker doing 10,000 requests over a period of 1 hour only has much less than a 1% chance of success. Now, of course, there's a lot of variables there about how many requests to make per second, but that was an initial thing. But what I do say is that because if you're the owner of the application, what you can do is observe and model the behavior of your users to try and answer these questions of how long should my session management be, or how long should an inactive timeout period be, how many concurrent users do I have, because you can create metrics. You can say, how many users do I have concurrently on my web applications? What's the average amount of time that they're active? How many of them actually use the logout feature? What that means is that if they're using the logout feature, if a lot of people are using the logout feature, that's good. If not a lot of people are using the logout feature, then you may want to shorten the amount of the inactive time before you expire it. And also, if you have a Remember Me feature, if a large amount of users use the Remember Me feature, well, that counters the inactive period timeout. Because what Remember Me says is that you can, instead of expiring your session after 20 minutes or 30 minutes, you can log in once and then 2 days later still go to the application. You don't have to give your password again. As a final countermeasure, data security I think is also important. Because these types of attacks, session management attacks, attack other users of the application, that you want to protect those other users' information. The easy way to do that is with masking. Credit card numbers only provide the last 5 digits of the credit card, only provide the last 3 digits, for example, of the social security number, and also only mask out the password, but mask it out with a fixed length string, so that someone can't guess, say, oh, this person has a 5-character password, this person has a 7-character password. Use a fixed length string. Also, for important transactions, perhaps when you change your password, or you update your email address, or you access a bank account, or you transfer funds, you can also just ask the user to re-authenticate. You pop up a window that says, please provide your password before you complete this transaction. That prevents the user from stealing the session token and replaying it in order to change your email address, for example. So, quick summary of that. If I haven't confused you too much, hopefully, or if I haven't gone off on too many tangents, is that looking at a session token, there are 4 things to look for. You can see how it's generated. Is it static or is it dynamic? Does it change each time the user logs in? Or does it stay the same every time the user logs in? Look at the content. Does it temporarily identify the user? In other words, does it have some type of anonymous random value, or does it permanently describe the user? Does it have their email address? Does it have a password? Does it have a username? Does it have a user ID? Look at the transformation. Is it just encoded, encrypted? Is it hashed? Because you can do some brute force guessing analysis on hash values to see what was actually used to generate it. Maybe it was only timestamps used to generate these hash values. So you can quickly reverse engineer that and attack the session management that way. And then, of course, manually, you look at the token usage. Can you replay it? Can you take someone else's token and replay it to change their password? What other pieces of cookie, what other pieces of information are necessary to complete certain transactions? And then I have references and a couple helpful tips. But at this point, I'd like to open up for any questions you may have. Question?
When you look at the possibility of expiring the session but not expiring the user, is it just having the session key, which in essence your tree you found a cryptographic key where you only use it for a certain period of time before you get rid of it, and then being able to move that session key to another session key, but still keeping track of that user over time. So in essence, the session key stays just for 30 minutes. The user could be on there for 8 hours or 10 hours or 12 hours without the notification.
Yeah, the question is about what if say we're using dynamic tokens, so we want to give a user, have them authenticate only once, but still change that session token on the user, but do it so that they don't have to re-authenticate or there's no interaction required. And in fact, PHP, I think 4.1 or 4.31 provides a session regenerate function, which does exactly that. So PHP provides the function to, you log in, and it's very good, for example, to give, when you have an anonymous user, the anonymous user goes to the login page. They get a session token. They log in, they've given their username and password. Rather than having them keep the same session token they had as an anonymous user, use the PHP session regenerate, give them a new token. And you can do this over a period of time so that you're changing it. Another thing that you can do, for example, PHP Groupware takes this to the extreme where it's almost like chasing a tennis ball. Every single page request has a new session token. So you have to go from the login page to the view profile page with the correct session token. Then when you click to go from the view profile to the change email address, you're given a new session ID. So that's actually taking it to an extreme where you actually have to have the exact user token and the exact page session ID for it. Another thing that is done is actually page-based session handling. Yahoo does this. They call it crumbs. I think MSN does this. A couple other sites do this by placing crumbs, not cookies, inside the web page so that a page request actually has a session associated with it, so that particular page is only valid for a particular user or for a particular amount of time. I have a couple of questions.
One, the common theme with your presentation is that you were always doing like 10,000 per hour. Why didn't you choose that number?
Yeah, common theme was 10,000 requests per hour as the attacker. That's once again the very arbitrary random value. There's no statistical reason for that. There's no good reason for that. That's simply an easy number to talk about. And it's also, one of the reasons I did choose it was perhaps thinking that 10,000 seemed to be about right for going underneath an IDS, going underneath, for example, Apache's mod DOS evasive type of module. So the point of but it's also, what I didn't mention is that there are other countermeasures to having many types of requests. And the reason that the importance on dynamic tokens is that when you have a dynamic token, you have a small time period, so the attacker has to do 10,000 or 20,000 or 30,000 requests per hour in order to get or per 20 minutes in order to get a valid attack. However, if you have a static token, a token that doesn't change, it doesn't matter what the request per hour is of the attacker. The request rate can be one per day, can be one per week, because as long as the website is up, as long as there are users who have created accounts on the web server, it doesn't really matter how many attacks you do. It's just whatever your patience is and whatever your paranoia level is about being seen by a log analysis tool or by a firewall rule. And second question here? Yeah, go ahead. The session regenerate, it gives you the one slide I did show was the phase-based analysis of PHP, which has a nice wide distribution over, I think it was a 32-bit window size, or 38-bit, excuse me, and the session regenerate function, it just basically goes through exact the same thing as a new user would receive a session token from. So session regenerate doesn't introduce any new, algorithmically it doesn't introduce any new problems, no time dependency. Other questions? Sorry. From what, any particular perspective? Well, I haven't looked at any SSL VPNs, and to see how the session's managed. So I can't answer yes to that. It'd be more of, with that, I'd suspect and just counter with where is the session being handled, whether it's being handled by the SSL session, and then whatever's protected behind it. For example, speaking to web apps, does the web app using the ASP session ID, or is it using just a user ID and assuming the SSL VPN is handling that particular session? So it's kind of an evasive answer only because I haven't looked at this. The question is, a lot of them use Java, and does that make it any less or more secure? And I think that the choice of language the session management is agnostic to, or should be agnostic to choice of language, because it's how you generate the token, how you manage the token. In other words, does it expire? What's the random number pool that it comes from? And then external to that is what other attributes from the client are you looking at in order to do data lookups, for example. Even if you're using ASP session ID or PHP session ID to manage the session, but you're giving each user a cookie value called user ID equals 1, 2, and what values 1, 2, 3, 4. If you're doing your database requests by looking at that cookie value, then you have very insecure session management, because all the attacker needs to do is change that cookie value, and it doesn't matter what the session was. They have a valid session. However, if you're on the server side, you do a session lookup and you say session object, foo, tell me what user ID you are associated with. And the session object tells you I'm associated with user ID 1, 2, 3, 4. And you do the data lookup based on that, then you have it securely managed. So that's why the language doesn't really matter. It's the handling, the manipulation of the data and what you handle and pass back between the client that is going to be the Achilles heel. Other question? Yeah.
I wanted to issue passport, but I was also looking for us to get a federated systems for the authentication necessary, session ID, stuff, and passing back and forth. And with that situation, if there's one system defining authentication for several websites, then you can distribute, you were talking 50 to 100 URLs, but now say you've got 50 to 100 websites with 50 to 100 URLs, so you can distribute your attack across all of those websites and still be attacked with a single session ID.
Yeah, it's absolutely valid. If anyone didn't hear, it's taking Passport as an example. Hotmail uses Passport, and name 4 other sites that use it. If you wanted to attack, you wanted to go through a plain text attack, or you wanted a bit flipping attack against Passport, MSP auth, and MSP prof cookies, you could do this against 3 different websites and against 1,000 different or 100 different URLs on each website. So the attack pool greatly increases. So that's definitely a valid point too. And one of the things that I didn't really emphasize too much is what the size of the attack pool. The requests per hour, requests per minute, what's really necessary. Because I think it's more important to simply from the application end use dynamic tokens, decrease the time window, because you can't stop someone from you running a zombie network and having 100 different computers doing 100 attacks each per minute, versus having 10 computers at 2,000 attacks. Those numbers, they're too easy to change. So it has to be done really from an application standpoint is where you're going to build your confidence. You're going to build the security of the management.
I guess bring that one step further, Dan, we're talking about the metrics here, with 3 different types of values. I mean, as one owner of the web server, you have to take into account of all the other web servers and actually get full access point, or all users can get across all the web servers to determine how long your session key should be valid.
That's true, and that's why I do actually kind of now regret not having put in a good metric on, should you have a 32-bit, should you have a 64-bit, should you have a 128? Probably as a rule, I think PHP takes it from a 40 to somewhere in 40 to 64. I forget the actual number, but if you're using whatever your seed value is, even if it's if you're using a 32-bit random number and you're taking hash, putting into MD5 sum, it's still a 32-bit. It still seems pretty good, but you have to counter that with how many valid users you have on your system. I was trying to think of good examples of this, but I don't know how many systems out there have more than 10 million or 20 million different registered users of the system. When you have, say you have 20 million registered users, valid users on a system, you have an extremely large target pool. And that just increases the chances of a successful hit when you're using static tokens. But when you go to the dynamic token range, it's a function of how many valid users are there per minute, unique users per minute, and what is the average time that user is active.
This is kind of a basic question, but assuming you're using HTTPS, what would be wrong with just using the username and password at every page request? If it seems like if you're able to guess that, then you'd be able to guess it on the bottom page anyway, guess the dynamic tokens.
Do you mean if the server expects you to send the username and password each time? So for example, that'd be sort of like using a basic auth over HTTPS. So if you had a web application that was expecting username and password each time, then that is your session management. So your session token is username and password and is based on that entropy. So in that case, every single request requires a valid credentials, and there's no, in that case, I can't imagine that's more secure or less secure than having a strong token. It's definitely not less secure than generating a dynamic token and just having that person use the session cookie. Because what you're doing, you're authenticating each request. So the drawback here is that when you only authenticate the login, you give the user an insecure session cookie, and then you ignore the user from that point on.
More likely to cause denial of service, because if you're probably going to have something in there like someone tries to password 4, 5, 6 times, 10 times, you may lock them out for a certain period of time or expire their password.
Yeah, absolutely. Yeah.
Because if you're training 10,000 on that combination, you're going to wipe them all out. So what would happen is that that web server would probably deny everyone eventually.
Well, yeah, what happens is that, I didn't mention brute force because brute force has many other potentials to it. You can either brute force a particular account and try many different passwords, or you can brute force a particular password across many accounts. For example, imagine a financial institution where your user ID is your social security number. And I know there are some banks that actually use this, some 401k management tool websites that actually do this, and your user ID is based on your social security number and a 4-digit PIN, for example. So take the PIN of 7777 and just guess different social security numbers until you get a hint. But one of the implications of having the username and password passed every single authentication is that one, you need to, of course, ensure the confidentiality of the session, because if it's not over HTTPS, and if you were to steal the username and password once, then you can log in at any other time. If it's dynamically generated, and you steal the session token, you can still only log in during that 20-minute or 30-minute time window. You can't wait a week and then be able to log in. So there's one implication there of using the username and password. Another implication of using username and password is that if you have any type of anti-brute forcing, or if you have any type of login restrictions, such as restricting concurrent login or lockout, then it's much more harder to control, because you have to apply it not just to the login page, but you have to apply it to every single page those credentials are being passed to. So once again, it's a development choice, it's an architecture choice of where you're going to handle user credentials, user authentication versus session management, session authentication. Other questions? Cool, I think it took us right up to almost the end. Oh, question, excellent.
I'm working on a project where applications where they are using proprietary encryption schemes. And I can also communicate with those documents, verifying whether tokens exist, et cetera, et cetera. Basically, this cookie doesn't exist until this particular session exists. I'm not sure whether it's dynamic or whether it's static. How would you go about basically breaking their proprietary encryption scheme so that you can show them that maybe that's not probably the best way? I mean, obviously there's trial and error where you're going to have, basically you're going to log in as yourself and then log in as yourself again, and then maybe there's another user and see if that cookies changed, but I've got literally 10 cookies and I need to review each single one and review each single number. Is there an easier way to do that?
Yeah, so with that, the first thing would be verifying. Just the first thing I would just verifying that all the cookies that they're sending, they're actually using all. If they define 4 cookies have to be set for the session, verify that all 4 cookies do have to be set. And that goes back, for example, to the Think Geek example, where you're given 4 cookies, but you only need one of them to be a particular user, and it's easy to change them. But then for checking the automating, trying to check, is the encryption good or is the randomness good? I can't give you a good response on the encryption, but definitely one of the things I would start with is just taking a large sample size, grab a large samples of these cookies, do a phase-space plot of them, try that. Pretty 3D graphs are pretty to look at, and they can convey some information. And for example, the ones I had up here, just by looking at them, they give you qualified information. They say this looks very dispersed. They don't give you quantified, so you can't say that because this has a standard deviation of 1.0, it's better because this one has a standard deviation of 1.1. So, but phase-based can give you underlying time dependencies that might show you predictability, and then also too, just examine the entropy. If they are doing encryption, or they're doing if whatever transformation they're doing, if they're that transformation, for example, if it's MD, say it's taking a timestamp to MD5, you're still taking 32 bits to 128 bits, but you haven't increased the entropy. If you just take a look at it, take 1,000 values, take 100,000 values, what have you, and just see how many actual bits of entropy you have. And even so, with timestamps, it's 32 bits, but over a small period of time, you're only really looking at 16 bits, maybe even 10 bits of entropy. 10 bits is only about a little under 5,000 values. So it's very easy to attack that in a small time period. So yeah, so that'd be one answer. Yeah, the graphs can definitely speak 1,000 words, whether you have distribution or you have clump or patterns. More importantly, patterns are ones to look at. Question? Well, I would say I think that using static dynamic tokens in PHP is a question. I think very simply is that if you use PHP's session object and their session ID, then you've got the dynamic. And if anytime you're rolling your own cookie, you're using the set cookie, then you have the potential for a static token, or at the very least you're using some type of static identifier. Yeah, I'll cross my fingers when I say it's okay to assume, because I don't want to get burned. But of course, I think that's why I put up these graphs, just to show the pretty graphs showing that these have large distribution. They don't exhibit any time dependencies. So whether you have ASP session ID, .NET session management, PHP, or Tomcat's J session ID, trust those. Trust what has been used. It's the same corollary with use DES, use AES, rather than trying to use XOR or some type of fancy homegrown crypto. And thank you for the questions. Appreciate them. And do have to close so that next session can come up. Thank you.